Sagen wir was? Hallo?
Hörst du mich eigentlich, Pascal?
Ja,
Okay. Ist okay oder? Weil es jetzt über
ja,
meinen.
alles gut.
Okay. So, dann merge noch. Ich habe von dir ein Topic hab ich reingemacht schon.
Ja, noch das zweite. Progress
Okay.
Validation. Ihr hättet relativ viel noch gemacht.
Okay. So, und dann muss ich den hier rausziehen. Das alles löschen. Hast du übrigens angenommen, die.
Muss ich noch machen.
Äh, okay, mach das, damit ich dich nämlich aus der. Also, es sind drei, du hast, glaube ich, drei Invites. Und die letzte ist für das Team und danach schmeiße ich dich wieder bei den anderen raus. Ne? Wir müssen nicht erst in die GraphQL-Org reinnehmen. Das war.
Ich habe nur Composite Schema Specs Invites.
Working Group?
Nein, direkt auf mich.
Nee, Composite Schema
Let me check Gmail.
ist der eine Team-Invite, musst du haben.
Hi Derek. Hi Martin.
Hi, Derek.
Hello.
How are you doing?
Hello.
We got snow today in Chicago.
We also like it's a lot of snow in
we,
Zurich.
we got a little bit of snow even.
Yeah. Like here it's really the problem is like the typical winter in Zurich starts end of November, lots of snow, and then punctually for Christmas it's gone. But then it comes back in January.
Yeah, we generally don't get much snow until like late December or more like January kind of time frame. So right now it's somewhat unexpected.
No, Derek.
Yeah, and Kamil probably is already. They already have 3 meters of snow.
No, there's no snow. I guess. Yeah, it's all gone.
Nice coffee machine. Nice grinder.
Oh yeah. Oh, thanks.
Hmm.
Oh, just a second. I'm almost done with merging. Is Shane already here?
Oh, not yet.
Okay, he's on the list.
Maybe he's updating Zoom.
He got a new notebook and has to research it like 5 times.
This is a second for him to arrive. Let's wait 2 minutes, and if he doesn't come, then we can start.
You guys remember that I made notes last time we spoke about the whole validation rules, everything that we discussed? Well, I didn't save it and restarted the PC. You know, this time when everything is super laggy on your device and you're just like, reboot will fix every problem, and then you just do the reboot and it asks you, are you sure you want to close everything? Yes, and then everything's gone. But it's not so
Get
bad
a
because
Mac. You should get a Mac because it sounds like Windows problem.
no, it's
He
it's
has a Mac.
Mac problem. But anyway, I've then checked the federation implementation with the test cases that you pointed out, Kamil, and then realized that the meeting we had last time was probably anyway not needed because it's so good. All the rules are there with examples. So that's exactly where I now get the information from for the validation.
But you can rewatch the episode of last time.
Yeah, but then I have to listen to myself speaking, and this is something I still cannot do. That hurts so much. I still struggle to rewatch my conference talks. Like,
Ah,
yeah,
there's Shane. Awesome. Then we are complete. Let's start, I think. Okay, let me remind you that by being here, we all agree to the GraphQL spec membership agreements and the GraphQL Foundation Code of Conduct. Today we have a couple of things on the agenda list, but let's start by doing a round of introduction in the order of the agenda. My name is Michael Stipe, and I'm the host today.
I'm Pascal from Chili Cream.
Shane from Apollo.
Camille from the guild.
Martin from Apollo.
And Derek from Apollo.
Awesome. So just as the first point, I created the maintainer group for basically the people that will have the rights to merge and help along on the repositories, and that is now in and set up. There is actually also Pascal in. He just has to because Martin and Kamil were already members of the GraphQL Foundation project somewhere, so I could just add them. Pascal has still to agree to be part of the organization.
That's not true. That's false information. I just agreed to it.
Okay, then you should be any minute. Yeah, there, Pascal. So this task is out of the way and works now. So you all should now have the right to merge pull requests. So you technically also have right to commit to master, but like should all be in pull requests. Okay. But then all of us can do it, and that makes it less dependent on me and Benji as a whole, and enables us to also work quicker on these things. We go back. So for today, we have a couple of points. There is a discussion on validation progress, and we also want to dive into the merge algorithms. This is also a longer discussion. Before that, let me just point out that Kamil did start on articles around federation for GraphQL.org, and he posted that to our chat on Slack. And it would be great if you guys have feedback, then give it to him, because his aim is to make it more visible, federation on GraphQL.org, because until today it's basically not existent, and to have it more predominantly also featured as a pattern on GraphQL.org and also connected then to our work in the working group. So it would be great to give him feedback on that. He asked for it. And with that, we can dive into validation, I think. Pascal, do you want to take it away?
Yes. I will. Let me just restart Slack for a second.
It sounds like Windows.
New device. It's definitely a Mac.
Ah, yes. Because when you want to share, that's what he means. Then you have to restart. Hi, Stephen. There's a pull request missing, Stephen.
On its way.
Hello. Sorry for being late. Second. Now the sharing should work, I hope. Yep. Share the screen. Okay, so this will be a quick one. It's more about so that you see that what's going on in the validation part of the specification. This list is getting smaller and smaller. This is what we have to do still. And there's also this list where we have open questions because I didn't save it last time. But essentially, we have to implement most of these rules, and or we have to specify them, and we have to specify most of these rules. These went in, I believe, last week, and this week these rules will go in, and there's actually a few more rules coming, and then we are actually in a good state there. Most of these rules are actually, surprisingly enough, these pre-merge validation rules. So a lot of the stuff around provides and so on, we can validate on the subgraph itself. Actually, provides is something that we have to validate afterwards, I just realized. But that's where we can this is the progress that we have on validation. So this will be another pull request that you can review, and especially give you the read and see if the rule is correct, because I just take the description that we have in Apollo Federation and then try to adjust it to Fusion. Sorry, to the composite schema specification. And there is also
Your sound just broke, Pascal. It crackled and then it's gone.
New machine. Still have to remove
Yes.
the wrapper from the microphone.
Is it back now?
Yes.
Yep.
Yeah, anyway. So that's in the next couple of weeks, this will be done. Then we will have all the validation rules, and we can focus more on the merge rules. And this is also what we should start discussing now. The idea here is that we basically just have a discussion about how we plan to merge the different type system members. And it doesn't have to be like structured or anything. We don't have to have like an algorithm at the end of this meeting. It's more that we all talked about, for example, how we will merge object types, what we'll do with input types, what we'll do with union types, with interface types, just so that we have a general understanding of it, and then we can go into more detail in the next few sessions, right? And I would say we just start with the easiest one, with the object type. And I think here we should talk about the shareable and what metadata we need to persist when we merge object types in the subgraph.
Yeah, at this point, we shareable is already validated at this point. Shareable is a pre-merge. No, it's a post. Where did we have that, Pascal? Can you quickly look it up?
I don't think we have it yet because it's still in the list here.
Okay.
Invalid field sharing. So it could be post or pre. Technically, we can merge. It probably makes sense to merge first. And then we check on the metadata after the merge if shareable, if one of the subgraphs didn't specify it as shareable.
But do we check return type compatibility during merge?
No, that's pre-merge.
It's pre-merge, but I thought so that's a pre-merge rule that still has the context of all the other subgraphs.
Yeah. So
there is Pascal, I think that was a bit a wrong disclaimer in the beginning. We have the subgraph validation. This is isolated on the subgraphs. Then we have pre-merge. Pre-merge already has the context over all subgraphs.
Yeah.
But it's something that we can validate before we actually bring these things together. And then we have post-merge, which is things that we can only validate after we basically have a composed schema?
Generally, as the rules are a bit more complicated in pre-merge scenarios, I would say pre-merge is the main purpose of pre-merge is that we make sure that a merge works. So, for example, provides makes sense to we actually have to validate it anyway after the merge. We could theoretically do it before, but it makes more sense to do it afterwards. But what we have to validate before the merge is, do we have a field which is an integer, and do we have a field which is a string with the same name that we try to merge, because this will fail during the merge process. And technically, we still have the context of the subgraphs after the merge, because we will need this. All the implementation will need this meta information anyway for execution in the end, right? So, for example, for shareable, even after the merge, we will know in which subgraphs this field is present, and if it was shareable, and if it wasn't, we just don't have to access it. So,
and then pre-merge rules. I mean, we specify them separately, but in implementations, you could actually perform the validation during the merge, right?
Yeah,
Yes.
we don't
Yes,
say,
you could also mix everything together. This is implementation detail. It's more about how we specify the algorithms.
Yeah.
It's easier to keep the validation apart from the actual merge.
So however you want to do it, as long
but the actual merge assumes that pre-merge has succeeded, right?
Yes.
I would say in the specification, but in the end, it's the output of the composition needs to be the same.
Yeah.
So you can do in which order you do it, and what you do first doesn't really matter. It's
Yeah,
just
and output is a bit like the output is the artifact that comes out. But in the end, if you show all the errors that are theoretically possible with the specification, or if you just if you just stop on the first error that you counter, is also something that is implementation detail, because there are complexities in it.
Yeah, it's just that invalid. All the composition is not allowed to pass if any of these rules are broken. But if all the rules are green, it doesn't matter in which order you go, I would say.
Yes. And it's also okay to fail on the first, or to fail after a certain amount of errors or whatever.
It's basically the same thing that we do with the in the
graphical validation.
We don't have an order where we specify in which order the validation rules have to run. It's just that an invalid query should never go through. And if
how like in Apollo, you try also to capture the most possible errors or doing composition, or do you fail on the first?
I think we. Oh, go ahead.
I was just trying to think too.
Yeah, I mean, I think we definitely capture more than one, but I don't know if there's a limit to it.
Yeah, I don't know that either.
Yeah, there are certain errors where you basically cannot go on, right? And that's okay, because sometimes the next validation step or the next merge step is blocked off by this error that you encountered, and then you stop. But like user experience wise, it's good to have like a bunch of errors. Like in the compiler, it would be annoying if it stopped for every little one.
Yeah.
But I mean, implementation details.
Yeah, that's basically exactly the description of what pre-merge does. It makes sure that we can merge the schema, that we then can validate everything else in one go. That's basically the idea. But what you do in the end doesn't really matter. I think that's also something that we have to specify. But what's the big question is what information do we specify? Do we persist when we do merge? For example, if a type or a field is not marked as shareable, we need to know in the post validation if this field was shareable or not. So it might be something that we want to annotate to the graph, right? If it isn't, then in the supergraph. If it isn't, then we have to validate it in the pre-merge.
I think it doesn't like this information shareable doesn't need to be in the subgraph document. Doesn't have execution relevance, so
it doesn't.
Yeah.
No.
Then,
But for other metadata, like we're not specifying the format of the supergraph, right? So we're just specifying the fact that that information is kept somewhere.
So we at some point, if we want to test stability, we have to specify a supergraph format. Otherwise, we will not have a testable outcome of composition. But like this supergraph format, I have no reservations in which way we go, and if it looks almost like the one that Apollo has, is okay.
Okay, yeah. Let's see how far we get with that.
Yeah.
But yeah.
Yeah, I think we don't have to like discuss the shape and form and the output of the composition right here and now. It's more a bit like what information we need to talk about. What metadata do we persist? Why do we persist it? So that we can write the merge rules, because the merge rules should also describe what metadata do we add in the different steps so that we have a reproducible outcome, right? Whatever it is in the end, we don't have to like say we now add this directive with this name to the supergraph, but it makes sense that we persist some information, for example, the lookup fields, that this is a lookup field and this is whatever. So that's something that probably is part of this object type metadata stuff.
Yeah.
So
Okay, so
yeah, go ahead.
yeah, so for types in general, we basically group them by name. That would be one of the steps.
And then we just take the superset of them, right?
Yeah.
No, not the superset, let's just say the union.
Distinct. Yeah.
That would be this, right? Something like this. And the outcome of this would be that we have ID name.
You need age. Oh.
Yeah, we need the age down here. This has to be shareable. So, and we say that like this. That's basically
So in our docs that I linked to it is basically groups those under like a union or intersection merging rules. So it's kind of like it's gonna be the similar kind of thing, right? For object types or interfaces or unions, how you would handle that, right? I think it's a similar approach. Do we need to? I'm wondering how much of a detail we actually need in those sections when we're merging those. Because I think one of the point of the contention was around the enums, because that's the most complex one. But we talked about it a couple of times. But yeah.
So the merge rules are also something that we have to specify, because otherwise we have the validation rules, but we don't specify how the types come together. Right, so we have to actually say that we have to specify the algorithm how we merge the different representations together. Otherwise, you could also just describe the validation rules as text. That's also something which which we want to be very specific about, right? Shouldn't leave room for interpretation, I would say, the merge.
I think we need to have it also for, yeah, also for the output types and stuff. Basically explain, you know, the decision making.
Yeah. How do we merge the keys? That's also the union, right?
No. The keys are actually like subgraph specific metadata in this model.
Yeah, that makes sense. You're right. You're right. So it's more something like that. I will just add this here. I can't remember what format we had, but I will just.
Yeah, I think we use like join key.
Yeah.
And then we specify the subgraph name in there. I
Is
forgot what the argument is called.
join type and a graph, and then the key as an argument.
Let's see. I mean, if we're using the
Like this, huh?
Yeah, key or keys, I don't remember. And the subgraph is a graph, if I remember correctly.
It's probably keys because you can have multiple keys per subgraph, right? So
No, it's actually a
It's
key.
the
I think it's a separate. The keys are listed in separate ones. If there are multiple ones, it actually tells you which ones are being
Mhm.
shown separately.
like this.
And subgraph is an enum, but that's like that's an so. But it's a very specific to how we define the supergraph format.
Yeah, you know, the thing is, in the end, we can still decide what we do with the supergraph format, what role it takes in the specification. But for the merge, this is very important that we specify at least what metadata we use. Doesn't really matter what format it is, right? That's something that we can just say as a note that in the specification we will use this in this format for the execution later because we need to have this
We need to make it visible in the description. So there must be like the execution directives described, even if we say you can deviate from that format. We somehow have to describe the composition. The question here is also like one of our key goals, how we verify the specification is by tests, right? We will have test suits. So how do we verify that if we cannot verify the format? Like I'm totally open to how we approach this format. Just we need something that is testable at the end.
And by the test, you mean just the composition?
Maybe I'm thinking also wrong about it. Like when we talk about this may be a different discussion, but how do we approach testability of that you fulfill the specification? Do we test the composition output? Do we want also what is the goal of interoperability? Do you want to be able to consume a supergraph format from a different composition tool? Like for instance, if you run the Apollo gateway with the backend from the guild, or if you want to run the guild's gateway with Apollo's backend, like does it work with the same format there? Is interoperability our goal in there?
I think that's a pretty big constraint on implementations, like that
Yeah,
level of compatibility.
I'm just throwing in like what is our goal as for the specification. I'm not saying that this is our goal. I just want to point out what is our goal here. Testability could also say we like each implementer provides a fully composed graph with all the subgraph implemented and the gateway, and then we just do outside tests, right?
Yeah.
We run queries and expect certain results. Could also be testability, right?
Yeah,
So this
I think
is-
I think it would be really nice if the test suite included like a number of subgraphs, like according to like the standard schema we use in the spec, and then we can specify a number of operations that run against that and expected results. Because I think the level of compatibility that we're looking for is especially at the subgraph level.
Yeah.
Like and that includes of course the metadata, like the lookup that we're adding in this specification. So we want to make sure that subgraphs compose and are able to contribute to execution.
And also for a client, just as a minimum level compatibility for the client, if you have the same subgraphs, you should have the same composed graph as visible through introspection.
Okay,
Yeah.
that's just what we like. If we just say like the observable result should be the same, like the outer schema, the public schema should be the
Yeah.
same, but the metadata that you actually have, it could also be different. It could also differ, like the directives that you put on there or whatever.
Yeah.
So the composition tool might not be compatible with others, but like the subgraphs that we compose have to compose into the same public API, and then the executable queries on that have to work like that. We definitely
Exactly.
find.
Yeah.
I think especially when we go into satisfiability and we go into specifying even if when we have outside in tests where we actually have a test suite, we run composition and queries and then we execute the queries. It would be really good if we described this. Again, we can have the note that you do not have to follow this like with the same format or whatever. But it would be good if we can rely on the metadata, just because otherwise it's really going to be really hard for us to write these behaviors, because we cannot say that we use the metadata that we annotated 2 steps before, right?
Yeah,
I think we can describe the metadata in the specification as part of the rules, but I don't think we should include a specific supergraph format. So not something like the joint spec that like our current implementation uses, because it really restricts
yes,
innovation, evolvability.
Yes, so what we can do is we specify, like in the GraphQL course specification, we specified basically a test schema. So we can here also specify a couple of directives and say these directives stand for this metadata that we preserve, but your this metadata can look however you want. And this is just exemplary, because like to be able to show, okay, this are 2 schemas like in an example, and they merge to this, and then you have to have these metadatas, like the SDL visualization in the spec, I think is important, but we don't have a full metadata spec. It's just this is represents this metadata.
And like even internally, we've had discussions when we came up with this supergraph format, because sort of the design goal here was to have one SDL file that sort of includes both the API schema and all the metadata that's needed for like query planning and execution. But there are definitely other formats possible. Like you can also imagine just keeping the subgraph schemas around and having some kind of container format. Like because right now, basically what we end up doing is for query planning, for instance, we recreate the subgraph schemas from the joint spec annotations on the supergraph schema. Like it's encoding the same information, but we still need to have like per supergraph schemas in some kind of format. Just to illustrate that, like the joint spec is just one format we came up with. And there are benefits to having everything in one file and to have that be sort of SDL. But it's definitely not the only way to do this. And I hate to put that as a restriction on the like within the spec.
Okay.
I wouldn't see it so much as a restriction. It's more that to write the chapters later, like the satisfiability and describe the execution behavior, even in the end, like even if we do not include this at all in the spec text, it would be good if we have this as meta information for us to actually track what's possible and what's not. Because otherwise we will, the thing is at some point we'll have we have these leaky abstractions, right? Where when we don't specify after this step, this is available, then in a later step in satisfiability, you will try to do something which sounds reasonable, but actually isn't because you don't have
but in theory, like the subgraph schemas are still available after merging. It's just that we've sort of encoded them in a different format.
Right.
But all the information is still there. Like we can just refer in our rules, we can just refer to the super subgraph schemas directly. We could just say the key directives on the like products
Yeah,
subgraph.
but the if you do that, it's very complex algorithms that you come up with.
No, I think it's actually simpler to describe because otherwise you end up having to describe how you basically decode the supergraph schema and extract the key metadata directives from the type.
If you look at like Fed 1 implementation, it doesn't have all this, and it's in some ways maybe cleaner to to describe if when you're just trying to focus on the algorithm of execution. But if for simplicity we did want to include this in the spec, I mean, we could just put like as a note, like these are just, we're using this to represent this in the spec that, that you need to keep track of the keys for each subject, and this is not, required to be represented in this way.
Yes, that was more like I was thinking, like we could specify just, okay, we, in this case, have these kinds of metadata that we need for the execution. And however you want to, however you want to have them in any format, you can do that.
But in the end, the metadata we're talking about is just a subgraph schema.
Yeah.
It's just keeping track of like where each field and like other information like key comes from.
But if you describe, for instance, an execution algorithm where you say, okay, now I need the lookup, and now you need to find the lookup on the subgraph, but you could like it's very easy if you can describe that you can just ask the type metadata for the lookup and you just get it, and you don't have to describe that you have to go to the query type, find the lookup, and then map from there the correct type and correct keys for this lookup. You can complete. Yeah.
What might be better then is if we're concerned about showing a supergraph schema and file and SDL, we all keep saying it's just metadata. Could we quite literally just say in plain text, like the resulting information you get is that you should be able to have a single place to go look up this type foo and know that, it has these 4 keys from these different subgraphs. The keys were defined here. Like don't use STL. Like just explain when you compose your supergraph, you should be able to look up this information very quickly or easily or whatever, right? Like that is the end goal. Just don't use GraphQL. Explain it.
The thing with GraphQL examples that we have in the specification, it's very simple to grasp, right? You write, okay, you have these 2 input types. This is what you get out. It's very easy to describe and also to understand for an implementer.
Yeah,
so we have to find a way to get to this level where we can use SDL. And I don't mind the format we use, even if we use exemplary Apollos format, if that is the problem that we have.
But I still think like I mean, and this is just showing like some metadata, but what you end up with in a real supergraph schema is basically like duplicating information from all the subgraph schemas. Like that's the information you're trying to extract from there. So I still think it's a lot easier to just describe
We can try.
this in terms of the
I'm-
API schema
yeah.
and the information that's in the subgraph schemas. Like that.
Maybe
We-
work backwards to this as we look at execution and think,
Yeah,
okay,
let's
in the execution algorithm, what's the best way to describe
yeah,
what we're doing?
I agree. Let's just dive in and hit the wall. And if we discover like this is easier to have like some metadata as directives, then let's go with that. Or if we find it's easy to describe it, then like
Yeah.
I don't care. It just has to be easy to understand. That's my my main concern.
I think the way it's represented here would actually work well. Like you can actually refer to the key directives in on type foo in subgraph B, and that's what we have here.
Yeah, the
But
only
we also need the composed. Yeah.
yeah. Yeah. I think that what we can think about is we need to have a way to express the preconditions in example. With the when you, for example, write the satisfiability or part of the satisfiability, then you need to have an input. You have to these two subgraph inputs, and you have the composed schema. You somehow need to describe it. So we can give this a go. The question is, what's in the specification? Is it more? Is it easier if we just have to specify this as an example? This is the input, then this is the counterexample, this is the example, or if we always have to specify the subgraphs as well. But we can go with
Yeah.
this, and then we see from there.
Yeah, we
Yeah.
tried out.
It,
And
it might be instructive to add like all the join directives you'd need, because it's not just the keys, it's also for every field you need to specify
Yeah.
like what subgraph contains
Yes.
those fields.
Yeah.
It actually becomes harder to see the result of the composed type in that way, because it's a lot of you're basically trying to represent everything in one type definition instead
Yeah.
of
Yeah, and I'm wondering whether we're basically skewed by existing implementations, because well, we have you know how stuff works, right? So we have a super graph format, and then we do that. But as Martin said, well, technically we do extract subgraph as the very first step in the query planning, right? So technically, do we actually even need that? But it's maybe just a bias of how stuff worked.
Yeah, I think it has a lot to do with the tooling side of things, right? It's much easier when you only have to care about parsing, reading one STL file, having all the metadata, and then working based on this in any tooling and you use. And if you think about it, the execution is just another way that this thing is used. So you have used in tooling where you check for subgraph usage, or you check for you validate queries and you do whatever. Yeah, so we can go with this, and then we'll see down the road if you have to change it. That also makes the validation rules, the merge rules, a bit simpler, because we don't really have to care too much about what we persist. And in the validation rules, we also don't have to care too much about what.
Yeah, we basically describe the public API, because like what we test is the public schema, and that's basically what we would also describe in the merge rules. Like, what would the public schema look like? The
yeah,
metadata.
there's one complication here, because inaccessible fields would still be part of the composed type, but they would be sort of filtered out for the public schema.
That's
Yeah, but if like how you preserve that, we have to say that it needs to be preserved. Oh yes. Otherwise,
Do they need to be in the composed type? Or
okay.
No, we don't, right? Because that's already the thing. If we now say, for example, let's say we have a field called So let's say this is a person.
Yeah, for instance, in the Fusion format, we didn't have that problem because we had basically a function specified that gets this field.
So if you think about this, and we just add, I don't know, the address, or let's make it easy, the city, and we say the city is inaccessible. It's probably written
Not there.
wrong, but it doesn't matter. And we have this like this, then in the composed schema it will not be there. Because we still have the information. When we say that we don't,
Necessarily.
when we say that
It's
we
in the
don't have,
subgraph, yeah.
it's in the subgraph. If we
And
specify
because the subgraph is available,
the information, the
Yeah,
information
you're-
is still around, right? So we don't need to have it in the composed schema.
that makes sense. So the composed schema here is really
The
the
public
public
schema.
schema, the API schema. Okay.
Yeah, this is also, by the way, like in the specification introduction, we specified that there's a composed schema, which is the public API, and the composed executable schema, which is a schema with metadata. So in this case, it makes sense. This is our composed schema. It's just the public observable schema.
Yeah, that makes sense.
Ah, this is the problem. Haha. Now we got it. Okay. So then we don't have to specify actually too much about object types. It's just that the only rules that we have to specify is that we group the types by name. That's given. And we union the fields of the non-inaccessible fields. Or actually, that's a different step. We remove all inaccessible fields. Because we have to first merge the types and then we have to remove the ones which are not there. Something like this.
Mhm.
Yeah.
And then we don't have to care about, actually we do need to resolve the requirements. We do not need to care about provides, because that's just
Yeah, we also we need to care about lookups. by the
yeah,
way.
yeah, but I mean the requirements in just object type merging, the requirements basically
It's
are
object type merging.
yeah,
But requirements are subgraph specific. They're not part of the composed schema, right?
yeah, but you remove the input.
You remove the arguments.
So let's say that we have
Yeah, you're right. With
we
the
have
new require, yeah.
we have something like this, I don't know, name. Doesn't make much sense, but you get the point. So we would annotate here.
Yeah.
Did we say require or require?
Require.
Yeah.
So that would actually end up being, oh, we already have address. I need a different
Yeah.
one.
No, it's actually, I think that's actually good because it's, oh no, but then you need to remove it from the other subgraph. Yeah.
That's
Yeah,
actually,
but doesn't matter. Just remove it from the other subgraph and it works out.
Yeah.
that's actually something which I haven't thought about yet. Do we, in this implementation with the theoretically in the composite schema, we could make this valid.
Oh, you're right. Yeah. And I think that actually makes sense because the requirements are subgraph specific. They're part of, so once and they're part of the implementation basically. Like one subgraph might like require information from another subgraph. The other one might have that information available internally, and they're
Yes,
still
you're right.
able to fulfill the
are
same
right, yes.
contract to get the address field. Yeah.
Then
I
we
agree.
have one thing that under this, there is another check now that we have to be careful about. We now have the problems of loops, which we don't have in the federation implementation, because it could be that the very basic very basic example, this doesn't make sense. But if it works in this example, it also works in more complicated examples. You could end up in this situation. Now this
Yeah,
doesn't.
but this is invalid. You
Yeah,
cannot.
it obviously doesn't make sense, but you cannot just check if address is in the selection set of the require, because you can have this over two fields. You can have it like this, right? So here you have the requirement of address which is actually on a third sub.
There's other ways we can create loops, and it does blow up composition today.
Right. Okay, yeah, fair enough. So it's more a satisfiability part thing where we actually see that we get into issues. No, it's a different step. Yeah, we'll see.
Yeah,
We'll figure it out. We'll
So,
figure it out.
but as part of the merge rule, like we're removing all required arguments, right? That's
yes.
Yeah, that will also have a change in validation. That means we can not necessarily, we have to, in validation, we have to ignore, in the pre-merge validation, we
We
have
have to ignore requires. Yes. Required arguments from the check if there
Yeah.
are.
Yeah. That's good. And then we have a post-merge where we have to check.
Just save it. Save it.
You're right. You're right. Merge.
yeah.
Yeah, I did just see it getting disposed.
Yeah. When we leave the scope of the meeting, it just gets disposed and then it's gone. So we have handled key, we have handled require. We can describe provides, but we don't have to.
No, I think that's definitely
I mean, we should have
a
examples.
post. Yeah.
Provides. That's actually doesn't make sense. So what could we use here?
You
Yeah, it must be a
you need another
composite,
type.
otherwise.
Yeah.
Yeah, just need something. No, that's right. Provides name. There we go. Rents. And provides also doesn't exist in the public schema, so that we can remove provides. And then
We have 10 more minutes. Just
yeah, it's fine. We have a few meetings to go. So
no, just that.
then we have shareable. We have handled this. That's basically just.
I mean, we have lookup, but that's maybe a separate.
Yes, because it's more complex. Then we have to, because internal. We have to recognize internal.
The internal only makes sense together with lookup, right?
Yeah.
Yeah.
But it means like internal doesn't erase both. But you could, if both are internal, it's gone. But if just one is internal, then it's still there.
Yeah. Let's call this the object types entity. Okay.
Yeah, it's not so clear, Pascal, because like with nested lookups,
Yeah,
we have specified it already on the directives, and I immediately see the use case.
Yeah, I'm not saying we don't have a use case. Just saying that we have to start with the easy parts first, and then we'll add the difficult part.
Yeah, but I mean, from a merge rule, it's simple. All lookups are removed. Like the lookup directives are removed. And if a lookup is internal, if all the lookups are internal, then it's gone. Then this field is not mapped. That's basically the rule.
Right. So we have person by ID. This doesn't have a key. So these are the lookup rules, right? Where you have an ID, you have person. You have address by ID, and we have. I should have just used the e-commerce examples because I know them now. Let's just book by ID. So this is subgraph A, and we have subgraph B, like this, and we have the public schema. And now we say that we have one that is a lookup, one that is lookup internal, and one we have which is only internal. And they actually do not have to exist on other subgraphs, right?
But they could also work in combination with inaccessible, right? Then they're just on all subgraphs gone, or do we exclude inaccessible from lookup? I never thought about it, just went into my mind.
Yeah, I'm not sure.
Could
Or
also
can you
be,
say that?
I don't want this lookup anywhere to be visible, but it still has a serves as a lookup.
It could be. I can see a use case for inaccessible. Well, as a shortcut to add internal. So like if you have 100 subgraphs and all of them have to be lookup at internal, right? That's
I don't think that's very surprising behavior. Like sort of affecting other subgraphs at a distance.
well,
I'm just throwing it in because it's
We
Well-
cannot have inaccessible because we would hide the field. Internal has a different semantic because if you have a person, this doesn't collide with the with, let's say, if we have address by ID and we have
yes, because they don't have the same structure.
yeah, if this that doesn't collide with this.
Yeah.
So I'm thinking like in the so I'm not an expert on a relay, right? But relay has the concept of IDs, right? Of all those objects. So there could be something that is used to query those relay objects by IDs, right? That you may want to keep it as internal thing to just access them, but maybe not publicly accessible. I don't know.
And in relay, you have node. Basically, the important field for relay refetches is node, the node field where you pass in the ID. And then it's just important that your entities implement node as an interface and have an ID.
I mean, it's
But like,
the
Go ahead.
issue that Derek is bringing up is we've had concerns from specific use cases and customers that, okay, you do the Rayleigh spec, like we understand that, but like who and what subgraph in a federated sense implements the global node resolver? Do they all do it? Does just one do it? Like,
they all do it, and the node, that's a complicated one because what we do in what we think about
Fusion.
doing in or what we do in Fusion is that you actually the node field is something which is a bit special because you route, and for us the node field, we can make use of the node field just like Relay does.
But we have a very simple rule, Pascal. If you want to be responsible for resolving a node, then you implement the node field on that, the node interface on that subgraph. And then we expect if this subgraph has a node field and implements for the entity the node interface, then it must be capable of resolving this node.
And for an incoming ID, does that mean you sort of you decode it and look at the type name?
Yes. So on the gateway, like we have a default decoder, but on the gateway you can specify how the IDs can be decoded.
Yeah.
That's just we by default expect that the format is name : ID. And we are actually not interested in everything after the colon. We're just interested in the first part, the name. We just look at that, and then we know where to route this thing. Basically, we look at the subgraphs that for this entity implement the interface and have a node field, and that are expected to resolve that. Otherwise, it would make no sense to implement the interface and have this all, right? And and you can specify an alternative serializer on the gateway.
Yeah.
so
Because there are, for instance, Facebook, for instance. Yeah, go ahead.
Keep going. Sorry, go ahead, finish your thought.
No, it's always like there is a little delay in the audio, but go ahead.
I was just thinking, I don't want to spend too much time here because we're almost done, but the problem comes around like when you want to change the schema and you want to like add a new node, but like not add it and expose it, and like do you like when do we start sending traffic to it? Because like you have to add it, and obviously there's the deployment patterns and everything. So I think, Derek, I know that the specific problem you're talking about, and I think the at internal would have solved that to help that specific use case, at least a little bit until you are like ready to release that change.
Yeah.
But
It's more so like maybe there is like some like a library that that you use across subgraphs that does something, right? And you have a common query to fetch parts of it in each subgraph, right? I was thinking like you could have add lookup at internal with every graph, which is fine. Technically, you have to still have it at lookup in every graph, so having that internal there, that's fine.
Yeah, the
Just an
lookup
extra guard against like exposing it by chance. Like if you do it at accessible means that it's not going to be public, right? Means no one can actually expose that. I don't know.
Stephen?
Because like right now, the equivalent in Federation would be entity resolvers, and those are all internal by default, basically, or they're strictly internal, basically. And so making this internal by default would be closer to that behavior.
Yeah, we discussed.
And
Sorry, go ahead, Martin.
well, I'm not sure where we landed on this, but I think you can only have one non-internal lookup for a particular type, right?
I mean, you can have as many as you want.
No, but I mean, well, I mean, if you have other arguments, but if you have like a person by ID, only one subgraph can be responsible for fulfilling that, right? Was that where we landed on, or did we?
Yeah, like if you do internal, that's what Pascal's argument is. You could have a person by ID lookup that is internal, and then the other graph has a person by ID also internal with other arguments. The field name is the same.
I
But
mean,
internal is basically we take it away.
No, but what I mean is,
you mean
there
this behavior?
Can you have more than one person by ID that's public, that's non-internal?
Yes.
I would say
Yes, like the decision there must be like, can this resolver verify the identity of the entity? Like, and there could be multiple of that if you have a properly distributed system.
Yeah.
It's more complicated, but it's definitely possible, and you don't want to take this away because that could optimize query planning.
Traffic steering is very important. If you have some weird behavior, and for example, one example is you use event sourcing. You anyway only store the events, and now you have a query which is really slow, and you identify it's because it does an additional hop that it doesn't really have to do. You actually want to go directly from the root entry. Now, for any other system, this is very complicated to now synchronize the data to the other microservice or domain service. With event sourcing, you just say, I want to have this aggregate also there. Now sync it, done. So I think that we don't even we can argue that we
don't need shareable. I think like the key, a lookup is by default shareable.
So then we just need internal, and we did talk about, by the way, Stephen, for context, we had a very long discussion about making lookups by default internal to mimic the entity resolver behavior. And I also would argue that this is probably the more common case. You will have more at lookup at internal resolvers. The reason why we didn't do it is because by default, all the fields that are in the subgraphs will be exposed. So that's the reason why we specify at inaccessible on fields that we want to hide. Now, the lookup would have this really weird side effect that the field is also hidden from the supergraph, from the public schema. So that's the reason why we chose to do the at lookup at internal. I believe that was the context.
So kind of for consistency, basically.
Yeah.
So that it's not an exception, and
it's this behavior actually. This behavior, you will have many more of these a classic, when you just lift and shift the classic federation implementation to this lookup behavior.
So the thing I'm thinking is like I'm on support this week for our federated graph with 500 subgraphs, and I'm thinking the pit of success when what most subgraphs are intending is not to be adding this field to the public API, and to make that the pit of success, kind of that they're not intending to actually change the public API. They're just trying to make a an entity available.
Yeah.
But I guess, I mean, as long as it's documented, maybe.
So
it
you're
doesn't matter.
arguing for this being rather having a public than an internal?
Yeah, having it be, you need to do something special if you want this to be part of the public API.
Did we discussing
Basically. Something like that, yeah.
Yeah, but this kind of looked ugly. But okay,
Yeah.
Like I don't make API decisions on that part, but it kind of feel weird.
Yeah.
One thing
I see what you're saying about as far as the consistency with the behavior that
shareable and
things are public by default. So
it's
but
to keep in mind that most API with different names here will probably look like this. And we could basically
but that is an assumption, Pascal.
well, it's how when you not use it as yeah, again, metrics would be great, right? To actually know, but at the moment,
if we're transforming an existing API, existing graph, then it definitely would look like that, right?
Yeah, but also it's not, it solves the same problem. So Federation and the Apollo Federation at the moment and the Composite schema specification, they solve exactly the same problem. So the same resolvers that you now have as entity resolvers will be in this schema. And it doesn't matter.
It depends on how you build your graphs with this. Like if you for instance rely on a relay pattern, you could just say node, add lookup, not internal, and everything is solved.
But no, that doesn't work, because then if I want to contribute fields, I cannot verify the identity. So on my subgraph, I'm not allowed to implement the node interface.
Yes, but that's exactly what I pointed out later. First, you don't implement the interface on one subgraph, then you're not resolvable there, right?
Yeah, but that means that as soon as I contribute fields to a type, I will have a lookup. And this is the entity resolver thing, right? Like, what's more common? Is it more common to have on one subgraph exposing a type only on this subgraph, or is it more common to contribute fields to a different type? That's the thing that we have to, for the API decision, to do, right?
Since I kind of reopened a can of worms, and we're over time, maybe I'll create an issue on in GitHub.
Yes,
just so we can kind of document some of this discussion.
On the spec repo, please.
Cool.
Yeah.
Because there we track all the issues.
If there's any way, I don't know how well annotated, actually you probably could get it from the supergraph. If there's any way, if you could just run a quick script to get numbers, if we say something like we have 150 public fields and we have 780 entity resolvers on all the different subgraphs, then this would give a bit of perspective, like what's the distribution of them, because it doesn't.
But you would need to align if the entity resolvers actually align with public fields, Pascal. It's not just easy to count the reference resolvers. You would need to look, do the reference resolvers align with actually the API surface that is publicly exposed?
Yeah,
it's a lot more difficult to do that.
Does that matter?
Yeah.
Yes.
Is it not just
because if the field is public, in our case, it would be a public lookup.
Yeah.
Yeah, but there is no other public fields, right?
In our case, like it's hard to correlate it.
Yeah.
Right. But just don't we just want to see an entity resolver is a non-public field?
Yes, but you can have a reference resolver that has the same shape actually as a lookup, as a publicly exposed field.
Yes.
And then it's not. Then it's actually public. Like it's not internal. Like the problem is the reference resolver is not persisted in the schema.
Yeah. You
That
would say
means
that
you have to look at the code.
if we have a
then analyze.
non-internal lookup, that would be a reference resolver and a public field at the same time.
You see, like, is there something at the query level that basically could serve as a lookup for this type that is an entity?
And for that, you
That
need
would
to
answer
pass,
the
in this
question.
case, Kotlin code or.
Well, I mean, at least we could see in the schema, like, is there a field at the query level that's public? But yeah, to actually know if there's resolvers, we need to do some static analysis.
Yeah, I see. Makes sense. Yeah,
I do need to
Jump
to
off.
leave.
Yeah. No,
Yep.
we
Yeah,
anyway.
we're over time anyway. So let's pick this up next week.
Okay.
I saved it.
Sounds good. Great. Thanks for the
Goodbye, guys.
discussion. Yep.
You too. See you. Bye.